Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from First Block, and it is a full house in here of two people. And on these problems, you want to make sure that you're always seeing these steps. And so maybe I can write these steps on the side. You always want to trace the base and redraw the base. And this is mainly for those cones and pyramids, but they can also work for the other steps as well. Step 2 is going to be make sure you can label everything and anything. Step 3, I believe, is our formula, so you want to make sure that you can write your formula. Step 4 is substitute your values for your variables. Substitute. Step 5 is simplify. Make sure you're following that very simple order of operations for yourself or GEMDOS. And step 6 is using those units to the correct power. So again, if you're doing surface area, again that's units squared, and if you're doing volume, however, that would be units to the third power. All right. So the first one, you're just going to find the volume surface area of this very easy rectangular prism. This one is a little bit easier since you are just labeling these values as such. So you can say 8 is going to be our length, 12 is going to be our width, and we can say 6, I can write up here, I can say 6 is going to be our height. Again, as long as you define those and stick with those, you'll be all right. So for surface area, it's going to be the following. It's going to be 2 times the length times the width, plus 2 times the length times the height, plus 2 times the height times the width. I can plug in my values, so this is going to be equal to, again, 2 times 8 times 12, plus 2 times the length, which is going to be 8, times the height, which is 6, and then also going to include, let's say, plus our last one. So we're going to have 2 times the height, which is 6, and 2 times the width, which is 12. I can have these 3 values added together as such, so it's going to be 192 plus 96 and 144. Add those 3 values together to get your surface area total. So the surface area is going to be equal to a grand total of 432 inches to the second power. Always circle your answer for yourself. However, for the volume, this is everybody's favorite since it is super simple. Our volume is going to be the length times the width times the height. Plug in those values as such, and so we would have 8 times 12 times 6 is just going to be the following. So it's going to be 576 inches cubed. All right. So that was for number 1. However, for number 2, it says what happens when you to the surface area after you double the width in number 1. So our new width for us is going to be, well, it's going to be 24. So what would happen? Well, if you plug in those values and see what you end up getting, for us, or for mine at least, you would end up with 768 inches squared. And so there's no real pattern to it, so there's no pattern. However, the main thing that you want to see is, well, what happens if you doubled the width? What happens to that volume? So if whatever you multiply by, whether that's a scale factor of 1/2 or you double or triple it, make sure that you are doing the same for the volume. So our new width is 24, and our new volume is going to be double of that. So it's going to be 1,152 inches cubed. All Alrighty, welcome back, boys and girls. It's your main math man, Mr. Cheng, coming to you live from Walker Grant Middle School. And for this problem number 3 on the mixed problems at the top. For number 3, the way it's going to work, again, is that surface area and volume. And now you have a square-based pyramid, so it's a pyramid for this. So we make sure that you can find the appropriate formula. So if we can take a quick glance at this, again, that's talking about that bottom left one. That's our square-based pyramid. And so, again, you want to make sure that you are tracing the base and redrawing the base. Since it's a square, you have a side length of 10. And we have the other side lengths are 10 as well. Again, be able to have those labels, and so if you have the label is going to be the area of the base, which is going to just be a side length to the second power, so that's going to be 100, and then the perimeter of the base, which is going to be 4 times the side length, so it's going to be 40. We also notice that the dashed line in red is going to be our slant height, which is L, and the dashed line in blue is going to be our vertical height, which is H, so that's going to be 12. Again, to use these labels, we want to put them into a formula, so it's going to be the surface area. Again, the formula for that is going to be as follows. It's going to be the slant height times the perimeter of the base divided by 2. And we're going to add the area of the base to that. Again, substitute in your values for your variables. So we'll say surface area is equal to, well, you know what? Let's actually just do and use the Desmos calculator. So let's see if I can slide this in here for ourselves. So we know for surface area, we said that it's going to be that slant height times the perimeter of the base divided by 2. And we're adding the area of the base, so it's going to be that big B. For the volume, it's going to be just the big B, which is the area of the base, times the height divided by 3. Alright, so again, the surface area and volume. So now we store our variables in, so we have big B is going to be equal to a value, and then we have, I kind of like to type these in first and then go to the numbers tab. So we have the slant height and the normal height. So we have our values. So we're going to have 12, 13, the perimeter of the base is 40, and the area of the base is 100. Again, notice how this works. It calculates it for you, it slices, it dices. You will have this for your entirety of the math SOL. Be able to use it to the best of your ability. Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shine, coming to you live from Walker Middle School, and I'm just doing finishing up the back for the mixed problems number 1, and we're working on number 4, and in a second, number 5. I'm going to be gliding right through this because I have that wonderful Desmos calculator here for myself. That way, it keeps it simple for everybody. As always, however, you want to make sure that you're tracing that base and redrawing that base. Since we have a cone, we have a circle, and we know that, okay, hey, it only goes from the side to the center, and so we know that's the radius is going to be 9, so we say, all right, the radius is 9. The area of the base, or big B, that's going to be that 3.14 times 9 squared, which is 81. And so let's actually say this on the side. Let's have just real quick math. Let's do 81, and then we'll have times at 3.14. Alright, so that's going to be 254, and again this is our big B, 0.34. Alright, so now, what else do we need? Well, we have this dashed red line. That's going to be our height, our vertical height, which is 22, and our slant height is going to be 25. Now that we have our labels, again, you can use that wonderful Desmos calculator. So again, if you maybe are watching this video full screen, or you only have this one window or tab open, I highly recommend that you take and either be working on the Desmos app, or just pull up the Desmos scientific calculator on another tab. You can split screen, whatever works for you, as long as you're using it correctly. Alright, so now for a cone, you want to be able to find the surface area first, and so we're going to have, again, we have big B, or the area of the base, and we're going to have plus, and we're going to have the 3.14, so we have 3.14, which is pi, times the radius times the slant height. So that's going to be our surface area. Then we have, for the area of the base, again, or excuse me, the volume of a cone is equal to the area of the base times the height divided by 3. Store that in there. Again, those triangles mean, hey, we need to figure out what these variables are. So again, we can have our variables defined one at a time. So we're going to have big B, which is the area of the base. We have our radius. We have our height and our slant height. Alright, so our slant height 25, our height 22, our radius is 9, and our big B, or the area of the base, is that 254.34. And bada bing, bada boom, we have our volume, which is, our surface area. Make sure you're paying attention to what you're looking for. Our surface area is going to be that 960.84, and then our volume is going to be 1065.16. Make sure that you're putting those units on carefully. So it'd be feet squared for surface area, and it would be feet cubed, or to the third power, for volume. Lastly, I want to have this number 5. And so, again, as always, trace that base and redraw the base, which is a square. We have 2.5 as the side length, and that means that all the others are 2.5. We have the area of the base is going to be equal to a side length to the second power, which is going to equal 6.25. We have the perimeter of the base, which is 4 times one of those side lengths, which is equal to 10. We have our height, which is that dashed blue line going from the vertex to the center of the base. So that's going to be 0.9. And then we have that slant height on the outside, which is in red, which is 1.5. I may want to clear some of these out here for ourselves, but maybe I want to keep it a little bit simpler, so I can back up a couple of these. So I don't need R, however, I do need the perimeter of the base. So I'm going to have P is equal to, thank you, P is equal to 10, I have the height is equal to 0.9, the slant height is 1.5, and the area of the base is equal to 6.25. However, we need to change up these formulas for ourselves. So again, the formula for surface area is going to be that slant height times the perimeter of the base divided by 2. And we're going to add in that area of the base, so that big B. However, the volume of a cone and the volume of a pyramid have the same, or at least the similar formula for us. So again, in conclusion, our value for surface area of this square base pyramid, it's going to be 13.75, and that's going to be centimeters to the second power. And then we're going to have the volume is going to be 1.8. Let's actually round it. There we go. Let's say enter. Let's actually round that answer for ourselves. So round our answer to the hundredths. So it's going to be 1.88 centimeters to the third power.